Hello, hello, hello. Solutions to problem 139. I promised that I would post and mention the names of the first 5 people who had the correct solution. So before we go ahead, let's just look at their names first. Aniruddha Ghosh, that's definitely an Indian name. Vishnu Vardhan, probably Indian name. Shrey Solanki, probably Indian name. Gaurav Yadav, definitely an Indian name. Maxillison could be anything, any country. Now, what is interesting that the correct solutions, these 5 correct solutions, came in within only 4 hours that I posted the problem. And then it took days before I got a total of about 15 correct solutions. But interesting that actually the first 7 came in within about 7 hours. All other answers, there are many, there are more than 100, were wrong. Yeah, what it comes down to is that people still do not understand the concept of F equals ma and the concept of angular acceleration. Extremely fundamental. So let's take a look at the problem. So here's the rod, length L and mass m. The rod, uniform rod, can swivel without any friction about point P. So it can do this. This is the center of the rod, the length is L, so from P to the center of mass is L over 2. Originally, you may remember, we had the rod in horizontal position, and I supported it here with my finger. It was easy then to demonstrate that in that situation my force upwards had to be 1/2 mg and the force at point P upwards also had to be 1/2 mg. Totally trivial. Now I pull my hand off. And now the question is, if we wait, say, 1/100th of a second, because I said instantaneously, well, nothing in life is instantaneously. Let's wait 1/100th of a second. And then the question is, when I have removed my hand, what is then this force upwards? Well, first, very simple, Newton's law, F equals ma. mg is in this direction, F is in this direction, equals ma. Now comes something that many of you may not remember or may never even have seen. If this is L over 2, this is P and this is C, and I displace it over an angle, the radius of the angle is L, over a distance ds, so this distance is in meters, then this angle is d theta. It's clear that for small angles, and d theta is very small, that ds divided by L over 2, which is the sine of that angle, to good approximation, and it is therefore also equal to d theta itself in radians. So ds divided by L over 2 is d theta. That's very fundamental. I take the first derivative. Here, so we get the ds dt, which is the velocity in meters per second here. And then I get here d theta dt, which is theta dot. Now I take again the derivative of this equation. The derivative of the velocity in time is of course the acceleration of the center of mass. So now we get a divided by L over 2 is theta double dot. A divided by L over 2 is theta double dot. Now we have what we've seen many times in problems for circular motions. F equals ma has to be replaced. F has to be replaced by tau. M has to be replaced by the moment of inertia. And A has to be replaced by the angular acceleration. In other words, we often see in books tau equals I times alpha. And that alpha then is theta double dot. That is the angular acceleration. So the torque about point P is of course this distance L over 2 times mg. You see that here. And that is the famous I alpha. I is the moment of inertia about point P, and theta double dot is the angular acceleration. I, for rotation about point P of this rod, is 1/3 ml squared. You solve these equations and you find that F equals mg divided by 4. That is by no means intuitive. But it is very interesting, isn't it? It's mg over 4. All right then, if you couldn't do this problem, don't feel too bad. It's rather fundamental though, I hope you realize that. And the fact that there were total only 15 correct solutions tells you that most of you really couldn't do it. Many of you have mg, many of you say the force at P is 0, many of you say the force at P is 1/2 mg. I don't know how they get that, but clearly they've never applied just Newton's laws. We'll be friends anyhow, let's face it, and that's all that matters. At 3:49 I mentioned that the radius of the motion of the center of mass is L. Of course it's not, it's L over 2. And I mentioned several other times it is L over 2. Okay?